Skyward.
Harness the power of the sun. SkywardSolarPower.com.
Now when we go to the monocrystalline and the polycrystalline panels, here and here, these are still the gold standard. When it comes to sheer power, when it comes to sheer performance, no other technology comes close to monocrystalline and polycrystalline. If you were to stack all of the technologies from top to bottom, putting your highest powered technology on the top, overwhelmingly, your monocrystalline panel is going to be at the top, followed by your polys, followed by your thin film. And thin film is a very, very broad category. Within the thin film category, there are many thin film subcategories. But your highest power, without a doubt, watts per square foot, if you will, right here. These modules are tough. They're reliable. They're durable. They have warranties that last 25 years. After 25 years, they don't just turn off. They'll keep on pumping up the power at a reduced rate, but they are still going to keep on generating electricity. So they've got a very, very long lifespan. They're not fragile. In fact, these are hail tested for a piece of hail, 1 inch in size, about the size of a golf ball, hitting it at 52 miles per hour. So they're pretty tough. There are many, many different types of monos and polys available, with all sorts of wattages, voltages, amperages that can meet the needs of whatever the scenario that is presented. And they come from all over the world. They're manufactured in the US, they're manufactured in Canada, in the Netherlands, in Germany, and of course in China. Then we get to a module that is very unique, and that's the bifacial. And in the bifacial module, sort of like that cylindrical module that you saw, this also has the ability to collect reflected light or diffuse light and generate power on the underside of it. So it's collecting power from the top and from the underside. One manufacturer of the bifacial types of modules, in fact, has the highest efficiency out there. And they claim that you can see potentially a 30% gain in power output from one of these bifacials. I think that's probably highly unlikely. That's probably in laboratory conditions, which are perfect. So you may see a gain in the field, maybe 15%, 18%. But what's going to dictate how well this works, how much increased power you will get, will be dependent on what's happening below. So again, in order to fully take advantage of the capability of the underside of the module, you're going to have to carefully think about the surface below. And again, you're looking for reflected light. But that's not the only reason why it's used. Primarily, the bifacial module is selected for its architectural appeal, its aesthetic appeal, in that you can be very, very creative with it. You can put a nice array of skylights with this. You can do a walkway like this, facades, gazebos, porches, all sorts of things, entrances of a building. So it gives you a lot of creative ideas with the module. And why you would be looking for that is because this module allows light to pass through, whereas the other modules do not allow light to pass through. And then we get to thin film. And I mentioned that thin film is a broad category. There are many different types of thin film technologies out there. And they have their advantages, and they have distinct disadvantages. Now, one of the advantages of thin film is that the photovoltaic application can be applied to many different types of substrates. So you can apply it to metal, you can apply it to plastic, you can apply it to glass, and you can have a module that is flexible. Whereas the other types of modules, of course, the cell inside, if you tried to bend it, it's going to shatter. So there are some advantages to it. Also, depending on the type of thin film, this particular one is a laminate. This one is more of a standard module type. You can have some very distinct weight advantages to it. They can be very lightweight. And on the module type, one of the advantages of module type is if you look here at this picture, aesthetically they look great. Look like a very nice shiny sheet of glass, not all polka dotty. Now, you will see, and maybe you already know of, some applications of the thin film laminate in a scenario like this. Now, say you have a strategy at your company where you're going for lead points and you want to affect the conditioning costs of the interior of your building, and so you put on a nice, cool roof, white, highly reflective. Now you want to ramp it up. You want to go for platinum lead points, and you call Skyward Solar Power and say, we want PV on our roof. I say, great, we come over there, and we put down this thin film laminate, just like this. Now what I've just done there, I've taken your strategy of a nice, cool, white roof, and I've kicked it right out the door by covering it in black. So instead of reflecting light, that array and that roof now becomes a giant heat sink. And this is absorbing heat. And that absorbed heat goes in one direction, and that's down. And that's into your building. So in that type of scenario where you're weighing energy costs, you might be kicking yourself and saying, well, yeah, I got my PV and it's generating electricity, but now my conditioning costs have gone up because I've increased my heat load with the building. So that may not be the best application. The other disadvantage to using thin film laminate in a scenario like this is that there is zero circulation between the module and the deck of the roof. You want circulation between the deck of your roof and the module. The modules work better. They're electric. They like that. Your roof will like that better. It's getting baked otherwise. But the other disadvantage is this system is going to get dirty, and it's going to get dirty very quickly. And if it's getting dirty quickly, you're going to have to put it on a routine cleaning schedule. Otherwise, you're going to lose your power generating potential. That leads us to this. The major disadvantage of thin film is that it can be 50% less power output than your mono or polycrystalline module. That's not very good if you've got a system that is dirty, and at best you're 50%. Now you may be at 30%. So instead of doing this, a better design would be to put a ballasted system where the monocrystalline or a polycrystalline type of module, you have great air circulation, you're not increasing the heat in the interior of the building, you're shading your roof, and you're getting twice as much power compared to this type of technology. And the other nice advantage to that is you don't have to have that routine maintenance crew going up on the roof to clean modules. Because when it rains, that rain is going to be sufficient enough to wash off the modules. Well, here they're flat, so they're not going to get cleaned. With the mono or polycrystalline module system in a ballast type of mounting, they're at a pitch, and that rain will wash off those modules very nicely. So there are very distinct advantages and disadvantages. And incidentally, this type of technology was created for the standing seam metal roof, where the module would fit in the valley between the seams. That's why it's got these long and narrow dimensions to it.